Hello and welcome back to another episode of Physics Partner. Imagine you are in your room and you shut the door. To leave, you have to turn the handle and open it, right? The door is a barrier and you need to use energy to get through it. That's how our everyday world works. Now imagine something so strange it seems like magic. What if you could just walk straight through the closed door without opening it? What if you could just appear on the other side while the door remains completely locked and solid? This is not magic. In the quantum world, this happens all the time. It's called quantum tunneling. Let's think of another example. You have a big, high wall in your garden. You throw a tennis ball at it. What happens? It bounces right back. Every single time. The ball is trapped on your side. But if that tennis ball were a tiny quantum particle, something impossible could happen. Every once in a while, when you throw the ball, instead of bouncing back, it would simply vanish from your side and instantly reappear on the other side of the wall. The wall would not be broken. There would be no hole. The ball just took an impossible shortcut straight through the solid wall. How is this possible? Remember, in the quantum world, particles are always waves and they do not have to definite location until we measure them. They exist as a cloud of probability. It's like the particle does not just exist in one spot but in a haze of possible spots around a central point. Most of the haze in your side of the wall, but a tiny part of the haze, that cloud of could be here, spills through to the other side. So when the particle's wave meets the wall, there is a small but real chance that the particle will be found on the other side. It is as if the particle tunneled through the barrier even though there is no actual tunnel. This is not just a wild idea. It is why our sun shines. The core of the sun is where tiny particles called protons needs to collide to create light and heat. But they positively charged, so they repel each other like two powerful magnets pushing against one another. This repulsion is a huge energy barrier. Classically, they should never get close enough to fuse, but thanks to quantum tunneling, there is a small chance they can tunnel through the electromagnetic barrier and stick together. This fusion is what powers the sun. So, the very light that lets us see comes from quantum tunneling happening billions of times every second inside stars. So, to sum it all up, here are the key takeaways from our journey into quantum tunneling. Number 1. The impossible shortcut. In our world, you need to open a door to walk through it. In the quantum world, particles can sometimes just appear on the other side of a barrier without going over it or breaking it. It's like walking through a solid wall. Number 2. No energy needed. Unlike rolling a ball over a hill, quantum tunneling does not require the particle to have enough energy to cross the barrier. It's a matter of probability, not power. Number 3. It's not magic, it's probability. Particles are smeared out, clouds of possibility. A tiny part of that cloud always exists on the other side of any barrier, giving the particle a tiny chance to be found there. Number 4. It's real and important. This is not just a theory. Quantum tunneling is the reason our sun and other stars shine. It allows particles to fuse together and create sunlight, which is essential for life on Earth. So I think it's enough for today. So thank you very much for listening and watching. I hope you enjoyed the video. I hope this video is useful for you. So take care of yourself and don't hesitate to write an email if you have any question, query, suggestion, and even classes are required. Take care of yourself meanwhile. See you in the next video. Goodbye.